Welcome back. This is Mr. Hassan's Maths channel. I'm now going to be answering question number 11 from the Cambridge October-November 2022 Pure Mathematics P3 paper. This is paper 3, variant 3. This is from 9709. And here we have a question. Part A is all about partial fractions and part B is about integration. So I'll split this video up into two parts. First part will be under partial fractions and the second part will be under integration. So the partial fractions part of this question, we have to split this up into two separate fractions. So we have 5 minus x plus 6x squared over, and we have 3 minus x and 1 plus 3x squared. So the first thing we do, we check, is it an improper fraction or is it a proper fraction? Well, if the order of the numerator is the same or greater than the order of the denominator, then it's an improper fraction. Then we have to deal with like the quotient part. In this case, the highest power on the numerator is x squared. So it's power of 2, and the highest power in the denominator would be x cubed. So therefore, it is a proper fraction, so we don't have to worry about any quotient part. All right, I'll split up into two proper fractions. And we have these two, these two factors in the denominator. One of them is a linear factor, which is 3 minus x, and the other one is a quadratic factor, which is 1 plus 3x squared. It's not a repeated factor. It's not like 1 plus 3x all squared, which would be a repeated factor. It's a quadratic factor, just a normal quadratic factor. So you'll have the numerator of this part of the fraction has to be an order less than that of the denominator. The maximum it can be is an order less than that of the denominator, so it has to be a constant. Can't be more than a constant, right? Because this has to be a proper fraction. And similarly here, the highest order of the numerator has to be at least 1 less than that of the denominator. So the highest this can be is linear. So we're going to write here bx plus c. We can't use a again because they'll say that these are the same. Now it's possible that the b is 0, in which case you end up with c over 1 plus 3x squared. But you have to put this here because that's the highest. That's how it could be, right? So don't get confused between repeated factors and quadratic factors. A repeated factor would be dealt with in a different way. If it was a repeated factor, you'd have had b over 1 plus 3x plus c over 1 plus 3x and then squared. You'd have to write that. But this is not like that. This is not a repeated factor. A repeated factor when you have the bracket, the whole bracket squared, or just x squared on its own, for example. All right, so now what we can do is we can try to find the values of a, b, and c. So what we do is like we multiply through in this identity by the denominator, in which case on this side you're left with 5 minus x plus 6x squared. And that's identical to, now when you multiply this by all of this denominator, the 3 minus x cancels out, leave you with a times 3 minus x, and plus, when you multiply this by all of these, the 1 plus 3x squared cancels out, so we're left with bx plus c multiplied by 1 plus 3x squared. Sorry, that gives you 3 minus x. Messed that up. When you multiply through by this, the 3 minus x cancels out, leaving you with a times 1 plus 3x squared. Sorry, I messed up there. So when you multiply through by 3 minus x times 1 plus 3x squared, the 3 minus x cancels out, leaving you with 1 plus 3x squared. And we multiply this fraction by all of this, the 1 plus 3x squared cancels out, leaving you with bx plus c. Let me put that neater. Bx plus c times 3 minus x. Okay, it's basically this multiplies that and that multiplies that. That's basically what happens. Okay, now we want to find the values of a, b, and c. Now we can do this by a variety of methods. Now I think what we can do is start with, we can say let x equals 3. When you put x equals 3, why did I choose x equals 3? Because then this bracket becomes 0 and you eliminate the b and the c from the problem. You're left with something with just a in it. So if I replace x with 3, I've got 5 minus 3 plus 6 times 3 squared is equal to a times 1 plus 3 times 3 squared. Okay, so 5 minus 3 is 2. That's 2 plus, that's 9 times 6 is 54. So that's going to be 56. Right? That's 9 times 6, 54, plus 2. And here we're going to have a times, and you're going to have, that's 3 squared is 9. 9 times 3 is 27, plus 1 is 28. So we have 28. A equals 56. So A is going to be 56 divided by 28. And I think that's 2, isn't it? That's 40 plus 16. Yes, yeah, that's 2. So therefore, we know that A is equal to 2. We found the value of A. And now we're going to find the value of B and C. Now, we can't really use a substitution now to eliminate the A. So we have no option now except to use what's called comparing coefficients. So what I'm going to do is I'm going to compare the coefficients of x squared. If I compare the coefficients of x squared, on the left-hand side, I have 6x squared. And on the right-hand side, I have a times 3x squared, which is 3a. That's 3ax squared. I'll also have, when I do bx times minus x, I'm going to get minus bx squared. So 3a minus b is equal to 6. So therefore, we can find what b is. So we have 6 equals 3 times 2 minus b. So we end up with 6 minus 6 is 0. So basically, b is equal to 0. b is equal to 0. Right, so we found a is 2 and b is 0. And now we need to find what c is. So we can, for example, compare, let's say, constants. Normally, constants are the highest and the lowest are normally easiest to find the values of because there's less terms. So the constant on this side is 5. On this side, you'll have a times 1, which is a, and you'll have, when you expand this, the constant will be c times 3, which is 3c. So a plus 3c is equal to 5. And we know a is equal to 2, so you have 5 is equal to 2 plus 3c. So we got 5 minus 2, which is 3, equals 3c. So we can say, therefore, c is equal to 3 over 3, which is 1. So c is equal to 1. So now we have a, b, and c. So we're going to have 2 over 3x, 3 minus x, plus 1 over 1 plus 3x squared. So the b became 0, so here you just got the c. So our fraction, we can say 5 minus x plus 6x squared over, and we had our fraction 3 minus x and 1 plus 3x squared times 1 plus 3x squared, splits up into a, which is, as we said, 2 over 3 minus x, and then we got plus c, which is 1 over 3x plus 1 plus 3x squared. 1 over 1 plus 3x squared. And there is the answer to this question. So it turned out that this b became 0. Now, I saw many of the students, when they did this, they actually put this as c over 1 plus 3x squared. So they kind of got away with it. All right. In the end, they ended up with a 1 here, and it worked out okay because b ends up being 0 anyway. But you will definitely lose a mark for your method because you should write bx plus c, because it's possible that b wasn't 0. In that case, it would definitely be wrong. So make sure that you understand that very carefully. And some people treat this as a repeated factor. As I said, it's only a repeated factor if it's the whole bracket squared. The whole bracket squared. Here it's only this part squared. Or it's like a factor like x squared times that is also a repeated factor. In fact, it can be treated in both ways, to be honest, that one. But anyway, that's the answer to question number 11, part A. As I said, 11 part B is like in a separate topic, which is integration. So I'm going to save that as a separate video so I can save it in a different playlist. So if you'd like to see part B, you can go to the playlist, which will be appearing at the bottom of this screen. So in the top of the screen, you'll have the playlist for this paper. So you can find all the questions from this paper, including part B, in that playlist. You also have here a playlist which is to do with the topic of partial fractions from P3 of Cambridge. And here we'll also have a playlist for P4 of Edexcel, because this is in P4 Edexcel. Okay, I'll put that there so you've got lots of different examples to look for. And I will, if you want to subscribe to the channel, you can subscribe over here. If you want to find part B of the video, it will be in this playlist over there at the end. Okay, so thank you for watching and see you soon.